Hello, hello. Let me know if you guys are here. And today we are going to. Hi, Angela. I'm good. Thank you. And today we'll be doing the AP Calculus exam multiple choice questions. And the topic is on implicit differentiation. Hey, hello, hello, hello. Bruno, hello, hello. Race, Khan, and Cold Tiger, and okay. Oh, okay. Hi, hi. Okay, a lot of people just show up, so I cannot really say hi to everybody. Hi. Hi. Okay, let's see. This will be really cool since I will be taking the AP thing in a couple months. That's right. Oh, 2 more months, right? And this right here is technically both for the AB and also the BC. And I'm doing the actual AP calculus here. Actual AP calculus exam multiple choice questions. Hi. Okay, I think from now on, I will just like whenever I do any kind of live stream, right? I will make an announcement on my Twitter account first, and you guys should go follow me on Twitter so you guys will know when I will be able to do a live stream like such as today, right? And also I will be wait for like 2 minutes and then I will start, which you have like about like 4 more seconds or so. Okay, so for the people who are here, thank you guys so much. I appreciate you guys watching my live stream. And we are going to do the actual AP Calculus exam questions. And we have 5 questions today. And in fact, I'm going to be running the LA marathon this coming Sunday. So after this right here, I will have to go and train. Namely, I have to go run on the street. But anyway, let's see. This right here is actually from 1969. And this is actually one of the oldest AP exam. And this is the first one that they released. But anyway, this is from both the AB and also the BC. Okay, the question is, if 3x squared plus 2xy plus y squared is equal to 2, then we're trying to find out the value for dy dx at x is equal to 1. Okay, this is how we can do it. We are going to just pretty much get the derivative of this, right? And you know we have to actually get the x value and also the y value. But let's just take a look of the derivative first. So right here, I will just go ahead and differentiate this implicitly because the y is not by itself, right? Okay, keep in mind, y is a function of x. And we are differentiating this with respect to x. And the derivative of 3x squared, this is just 6x, right? Okay, sorry, there should be nothing there. Just 6x to the first power. And then for the next one, it's just going to be 2x y, and we have to use the product rule because 2x is a function of x and y is also a function of x. So the product rule I'm going to use is that I'm going to keep the first function, namely 2x, and I will multiply by the derivative of the second function. Derivative of y, I will just write that down as dy dx. This right here represents the derivative of y because y is a function of x. And we will have to add the second function, which is y, and we multiply by the derivative of 2x, that's the first function, and the derivative of 2x with respect to x is just 2. And then we will move on and we add the derivative of y squared. Okay, bring the 2 to the front, minus 1, so we get 2y. But because y is a function of x, and we have to use the chain rule, right? And then we multiply by the derivative of y, which is dy dx, and then this is equal to the derivative of 2, which is 0, like that. It's a, okay, yeah, I don't know. Right here it says, we are trying to find out the dy dx when x is equal to 1. And you have 2 ways to go about this. If you're in a hurry, you can just plug in x is equal to 1 into the original, so you can solve y, and then plug in x and y into this equation now and solve for dy dx. But let me just do some exercise with you guys, because sometimes they will just ask you for the dy dx expression. So let's do that. So with that being said, I am going to keep this term and this term on the left hand side, because both of them have dy dx. And I'm going to factor that out. I will put that at the end though. Let me write down parentheses with 2x plus y, and then I will put down the dy dx at the end. And the reason I don't want to put this in the front is because this right here is the derivative. It looks like d dx, which means we are going to take the derivative. So that's the difference, okay? And we will move this and that to the other side. So we have negative 6x minus 2y like this. And in the end, we can of course just we can just divide both sides by this. I am not taking the AP test. That was long time ago for me, but I'm just want to do this with you guys. And for the people who would like to download the file, you guys can see the link in the description. Okay, the file is there for you guys. So if you guys want to work on these questions, you can go ahead and do so as well. But anyway, this is the expression for dy dx, and I will have to calculate the value. All right. So I'm going to just plug in 1 into the original so I can get the y value. So it looks like I will have to use a blue pen to make it stand out better. Plugging 1 into here, I get 3 times 1 for x, right? And then square that, plus 2 times x, which is 1. And then the y we don't know, and then plus y squared, which we don't know yet. And then this has to equal to 2. From here, you see 1 squared is 1 times 3 is 3, plus 2 times 1 times y just 2y, and then plus y squared, and this is equal to 2. Now I will move the 2 to the other side, and I'll put this down first. So I'll write this down as y squared, and then plus 2y, minus 2 on both sides, so we'll actually get 3 minus 2, which is 1, so that's equal to 0 like this. Factor this real quick. This is y plus 1 squared equal to 0. From here, you can see y has to be negative 1. So when x is equal to 1, when x is equal to 1, y is equal to negative 1, I will just have to plug in here. And yes, I know I can reduce the fraction, but I'm not going to because it doesn't really matter. And in the end, you'll see the tricky part about this. Plug in negative 1 into y, and then on the bottom, 2 times x is 1, right here, and then plus 2 is 2, y is negative 1, like this. Oops, like this, yeah? Okay, if you would like, you can work out the top. This is negative 6 plus 2, which is negative 4. But it doesn't really matter because on the bottom, this is 2 minus 2, which is 0. So what's the best answer? Undefined. So the answer will be E. Okay. Yeah. Some people will say you will have like a vertical tangent line, but whatever. But based on the answer choices that we have, E will be the best answer, right? So imagine if you're just taking a test and you choose the best answer every single time. So this is pretty much it for the first one. And now let's move on to the second one. And by the way, how's the picture quality for the camera? I forgot to clean my lens. Can you guys see okay? Bad? Seriously? Okay, let me see if I can find this. Sometimes it's good, it goes, let's see. Let me just use my shirt to clean this. I don't know if it will work or not. Let's see. Okay, so no matter of the Kenny Redder question, it's okay. Do UI inspire. Thank you, Rash. All right, let's continue with number 2. So right here it says if tangent of x times y is equal to x, and we're trying to find out dy dx. And once again, we have to use implicit differentiation. So right here, let me just put this down dx, okay? Now, derivative of tangent of something, you are going to first write that down as secant square stays the same, right? And you have to use the chain rule, so you have to multiply by the derivative inside. But the derivative inside, we have to use because this is x times y. So we multiply by the following. Let me just down in red. Product rule in action. We keep the first function and we multiply by the derivative of the second. Y is the function of the, okay, sorry, let's see. How about if I zoom in a little bit? To be honest, I am using my phone and then I am not on Wi-Fi. Maybe that's why it's not clear.